Okay. Um, Let me see here. This needs to turn on. This needs to turn on. Those need to lock. Excellent. Hi, Shafam. How are you? So this is an interesting little opportunity that I'm taking. It is a Saturday night, and I'm sitting here doing mathematics, which is not everybody's ideal way to spend, uh, spend the weekend. However, as a teacher, I have a limited amount of time um, with respect to what it is that I can and can't do. Unfortunately, that's the way that the world works. I figured I'd take some time to actually I would do some of the assignments that I've given my students in the past, um, with the hopes of providing them with an additional resource to look through while they check over their work. Now, the thing is, I need to find a good way to import this into my whiteboard software. I don't know what the best way about going to do that is, aside from inserting. Oh, you can add PDF pages. Interesting. Okay, let's attempt this. We'll see if this works. I'm going to save this to my desktop, and we're going to see if inputting a PDF inputting a PDF helps in this process, because if it does, wow, that's going to be oh my gosh. Insert all pages. Holy smokes, I had no idea you could do this. Hi Dylan, how are you? Wow, okay. This is beautiful. And now I can write on it. Awesome. Okay. That's fantastic. I had no idea that you could do this with the whiteboard software. Um, so this first assignment that I had given my students, it is called a diagnostic review of mathematics. So this is for a grade 10 applied mathematics course at the high school level. And in this assignment, my students were required to work with manipulating integers. There's a little bit of order of operations, the difference between an expression and an equation. There's some stuff about fractions, and then there's just a few like quick word problems. I figured I would take the time to go through and actually like record solutions for these things. I think that it would be beneficial for them. So that's what I'm going to do. I'm just going to lock these to my whiteboard so that they don't move around. And I'm just going to kind of jump in. So this first question, which I kind of put together rather hastily, it has to do with adding and subtracting integers, which for a lot of students can be very tricky. The idea of positive and negative numbers. And these questions are purely meant as a way for them to assess whether or not they understand what's going on with respect to positivity and negativity. With this first question, we have positive 10, subtract positive 2. This is effectively the same thing as 10 minus 2. That's all that is saying, is 10 minus 2. The positive numbers are not there to trick you. If anything, you can take a look at this positive symbol right here, in between the 10 and the 2, and you can even apply it to this positive sign. It makes it negative, because a negative multiplied by a positive is a negative. So in this case, we have 10 minus 2, and as I'm sure most of you know, 10 minus 2, this is equal to 8. So the correct answer for this would be positive 8. For B, we have negative 5, subtract positive 11. So we're starting as a negative number, and we're subtracting positive numbers. We're going to become even more negative than we currently are. So negative 5 subtract positive 11. is just the same thing as saying negative 5 take away 11, which in this case is negative 16. So that integer is negative 16. We have negative 4 plus positive 5 for question C here. We're starting at a negative number, and we're becoming more positive. I'm adding positivity to this negative number. So in this case, this phrase, this expression can be written as negative 4 plus 5. Now, this is not negative 9. We're going to start from negative 4, and we're going to start adding numbers so that we're getting closer to 0. So we're going negative 3, negative 2, negative 1, 0, all the way up to positive 1. So our integer here is 1 with a symbol. It is positive 1. For question D, we have positive 6 subtract negative 5. So in this case, we're starting at a positive number and we're subtracting negative numbers. We're getting rid of negative numbers. And, we have a minus symbol right next to a negative symbol. We can actually rewrite this so that this is saying 6 plus 5. When you subtract a negative, that is like adding a positive. That it's called the snap rule. Subtracting a negative is like adding a positive. So in this case, we have 6 plus 5. This is 11. And, when we write it with a positive or a negative symbol, we have positive 11. In question E, we have a number of different integers back to back to back. So we have negative 1 plus negative 5 plus negative 9. So I'm starting with a negative number, negative 1, and I'm becoming even more negative. I'm adding more negativity to this number, to this integer. So negative 1 plus negative 5, I can rewrite this so that it is saying negative 1 take away 5 take away 9. This is the same thing. If we want to really break this down line by line, we can say this is the same thing as negative 6 take away 9. I wonder if there's a better way to write this so that I can get all of this in the same area here. So we do negative 1 take away 5 take away 9. This is the same thing as saying negative 6 take away 9. So I've brought in the negative 1, subtract 5 together. And now we have negative 6 subtract 9. So we're going to go even further negative, even further. And we're going to push ourselves all the way up to negative 15. So that answer to that expression is negative 15. For question number 1F, we have positive 12 subtract negative 6 plus negative 4 subtract positive 9. So again, multi-step integer question here. It's best if we just try to simplify it. So here we have 12. We're subtracting a negative. This is the same thing as saying plus 6 plus negative 4. This is the same thing as saying subtract 4 minus positive 9. This is the same thing as saying minus 9. If we try to simplify this a little bit, we have 12 plus 6. This is 18. Minus 4 minus 9. 18 minus 4. Well, this is 14 minus 9. And then 14 minus 9 is positive 5. So if we write this as an integer, we have the plus sign and then 5. So that is how you do that first page for the diagnostic assignment. Very, very brief overview of addition and subtraction rules for integers. And as I'm sure you've guessed from the video and it being uploaded as a live stream recording, this is a live video. So there is a chat. Hello, Ratmus. How are you doing? I'm recording a video for my students. That's a bit of a tutorial, I guess, for them, for their math skills. In this question, we're solving expressions with multiplication and division of integers. So for 2a, we have plus 6 multiplied by negative 4. So we have to recall our rules for multiplying and dividing integers. When we multiply integers that have opposite signs, the product is negative. So in this case, we have plus 6 times negative 4. This would be negative 24. 6, 12, 18, 24. So that first one, 2a, should be negative 24. For 2b, we have negative 2 times negative 4. So we're multiplying two negative numbers together. The result should be a positive. So in this case, negative 2 times negative 4, this is positive 8. In C, we are dividing two negative numbers. We have negative 24 divided by negative 4. So in this case, 24 divided by 4, well, 4, 8, 12, 16, 20, 24 is 6. And because it's a negative divided by a negative, our answer is positive. D is a little bit tricky. D has a negative symbol right in front of the brackets here. We've got to pay attention to that. But on the inside of the brackets, we have negative 8 divided by positive 2. So 8 divided by 2 is 4. In this case, negative 8 divided by 2 is negative 4. So on the inside of the brackets, we have negative 4. But we also have this negative symbol on the outside of the brackets. So when we see two negative symbols next to each other, we have to remember that those negative symbols kind of cancel each other out. Subtracting a negative is like adding a positive. So in this case, negative negative 4, this is positive 4. And that is how we do question number 2. How's everything going, Ramis? How are you? With question number 3, it says, what is the change in temperature when a customer walks from the chilled vegetable section at positive 4 degrees Celsius to the frozen fish section, which is set to negative 18 degrees Celsius? And you get a few marks, 1 mark for the actual expression, a mark for the correct answer, and a mark for the therefore statement. So in this case, this person is walking into a part of the grocery store where the temperature drops to negative 18. They're sitting at positive 4, and it goes all the way from positive 4, positive 3, positive 2, positive 1, 0, negative 1, negative 2, negative 3, all the way up to negative 18. So we have to find this change in temperature using some kind of expression that we have to make up ourselves. They're asking for a change in temperature. They want to know the size of that temperature difference. So, for example, if we take a ruler, okay, we draw a straight line. And on this line, we represent the two extremes in this question, right? So we put one extreme on this side, one extreme on this side. We have positive 4 degrees Celsius on this side. And we have negative 18 degrees Celsius on this side. The question is essentially asking us, and we'll say that 0 is, it's right about here. Okay, 0 degrees Celsius. The question is essentially asking us, what is the difference between all of the numbers that exist between one end of the extreme to the other end of the extreme? So in this case, if we actually draw out those lines, so this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It's essentially asking us to count all the way from positive 4 to negative 18. Now, that's kind of a hassle to have to count that far. You can do it this way if you want to, but there is a different way to do this, and it's by writing an expression. So if we say that positive 4 subtract negative 18 is equal to, we'll say the change in temperature, That triangle there is a Greek letter. It means delta. It's often used to represent the change in. We can say that positive 4 subtract negative 18 is the change in temperature. So in this case, 4 subtract negative 18, this would be positive 22. That's the change in temperature. So we've gone down from one end of this spectrum, of this line, this gradient, to the other end, and that entire distance, that's 22 units. So the change in temperature is 22 degrees. It's gone down 22 degrees. There was a pretty common misconception that it was just 14, because you were finding the difference between the numbers 4 and 18. But that's not necessarily what we're looking at here. We're looking at the actual units, the integer units from 4 all the way up to negative 18. Or I guess I should say down to negative 18. And we get a mark here for the correct answer, which would be 22. And we get a mark for a therefore statement. So we would have to write something like, therefore, the temperature change is 22. And we can say 22 degrees Celsius. And that works too. Our fourth question there, it's asking us to simplify expressions and to not forget to use bed mass. So bed mass, this is our way of saying brackets, exponents, division, multiplication, addition, subtraction. This is our order of operations. We need to use the order of operations when we see multi-step calculations like this. Now, it's important to recognize that this symbol x right here, this is not meant to be a variable. This is meant to be the multiplication symbol. So when we see that multiplication symbol, that's one of the first things that we should be looking at when we're actually going through and doing bed mass here. Because we need to, again, solve these things in order of operations. So I'm not going to touch the negative 5 for 4a, but instead I'm going to actually do this multiplication right here. We have positive 4 multiplied by positive 2. So I'm going to carry over my plus sign. That's right in front of the 4. And then I'm going to evaluate what positive 4 and positive 2 are. So positive 4 and positive 2, that makes positive 8. Now I have a phrase that says negative 5 plus positive 8. In this case, we get positive 3. For 4b, we have another step of bed mass that we need to be aware of. We have this multiplication symbol right here. So we're going to have to evaluate that first. So we say negative 8, subtract negative 1, plus, and in this case we have positive 11 multiplied by negative 5. So 11 times 5 on its own, this is 55. 11 times negative 5, we have to flip the sign. We have to make it negative. This would become negative 55. Okay, and now we only have addition and subtraction left in this question. So from here, we can start doing addition and subtraction from left to right. So negative 8 subtract negative 1. Well, that's negative 7. I'm removing a negative from an already negative number. And now I'm adding negative 55. So negative 7 plus negative 55. This is negative 62. Okay. Just give me one moment. I need to answer a message. apologies for that. Bed math. Not quite, Ramus. Bed mass. Okay, this last question. We have a few different operations we have to be aware of. We have this multiplication symbol right here, but we also have brackets and eventual multiplication into the brackets. So let's solve this one step at a time. Okay, we have 4 take away 1, which is 3. So when we evaluate the inside of that bracket, it's going to be 3. Then we add whatever is left over. So in this case, we're going to say positive 2 multiplied by negative 3. Okay. We're going to continue moving from left to right. We have 2 multiplied by 3. We have a number next to a set of brackets. That refers to multiplication. So 2 times 3 is 6. Or in this case, we can say positive 6, but just 6 is fine. We are adding the product of positive 2 and negative 3. So in this case, positive 2 multiplied by negative 3, this is negative 6. So we have a statement here now saying 6 plus negative 6. Well, this is the same thing as saying 6 take away 6. I wonder if there's a... There we go. 6 take away 6. Which I hope, from watching, you know that that's 0. We have 6 take away 6, which is 0. Okay. That was the bottom part of this particular section of the assignment, where we were simplifying expressions using addition, subtraction, multiplication, and division of integers. And we had to use bedmass here. Right? Bedmass is that set of rules that we use in order to effectively solve problems in the same way as each other. Otherwise, math would be just way too chaotic. It wouldn't make sense. Number 5 has fractions. Yikes. People hate fractions, right? We have to simplify these fractions and utilize fraction rules that we discussed in class. Okay, so in this case, we have 3 over 4. I'm going to make these a little bit bigger so that you can see them. We have 3 over 4 plus 1 over 5. So in this first question, 5a, we have 4 and 5. These are our denominators. In order for us to add fractions, if we want to add a fraction, we need to have common denominators. This is the first thing that we do in every single fraction question that involves addition or subtraction. We need common denominators. I like that, Ramus. Yes, 1 out of 5 people hate fractions. 3 out of 5 people don't understand fractions. And 4 and 5, those are not common denominators. They're not. We need to make them the same. So a way that we can do that is we can figure out what the lowest common multiple of 4 and 5 are, and we will use that multiple in order to determine our lowest common denominator. So if I count by 4s, we go 4, 16. Oh, that's not, I don't know why I said 16. 4, 8, 12, 16, 20, 24, 28, ... If I start counting by 5s, I go 5, 10, 15, 20, 25, 30, ... There is a number that 4 and 5 both share. That number is 20. So 20 is the lowest common multiple between 4 and 5. And we're going to make that our lowest common denominator. In order to do that, we have to count or figure out how much that we have to multiply 4 by in order to get to 20. So if I want to multiply 4 by a number, I have to multiply it by 5. And if I want to get 5 to 20, I have to multiply it by 4. So when I take a look at my fractions here, 3 over 4 and 1 over 5, I'm going to just move to the right here because we're going to run out of space. I'm going to rewrite them 3 over 4 plus 1 over 5. I can actually put these in brackets. And I can write that I'm going to multiply that entire first fraction by 5. And this entire second fraction by 4. And by the entire fraction, I mean both the numerator and the denominator. So 3 times 5 is 15. 4 times 5, this is 20. 4 times 1, this is 4. And 4 times 5, this is 20. And now that these two fractions have the same denominator, they have the lowest common denominator, I can add their numerators. So 15 over 20 plus 4 over 20, this is 19 over 20. And this can't be reduced. This is as low as this fraction can be made. That is its simplified form. We can't reduce that anymore. So that would be your answer for that first one, for 5a. 19 over 20. Now, for B, for 5b, I'm going to write this again just a little bit larger so you can see it. We have 3 over 7 divided by 2 over 8. And one of the nice parts about division and multiplication of fractions is that their rules are much simpler than addition and subtraction. We don't have to worry about common denominators. When we divide fractions, what you can do is you can take that second fraction and you can flip it and then multiply. Very, very convenient. When you multiply fractions, all you have to do is multiply the numerators and the denominators. So in this case, 3 over 8 and 7 over 2. So 3 times 8, well, that's 24. 7 times 2, that's 14. And if I want to simplify that even further, I can take this fraction and I can divide everything on the inside by 2. Come on, nice 2. There we go. So 12 divided by 2, 24 divided by 2 is 12. And 14 divided by 2, well, that's 7. So that's our final answer right there. That can't be reduced any further. I mean, we can write this as a proper fraction if we want. We can say that this is 1 and 5 over 7. That's also the correct answer. But you can leave it as an improper fraction. That's fine. And that 19 over 20, that was our answer for that first question for 5a. For question 6 here, it says evaluate each expression using substitution. Okay. So substitution, we have to take the values of a and b that they give us in the question, and we have to substitute those in. So our equation here is 6a plus 3b. It's saying to evaluate this expression where a equals 3 and b equals negative 5. So in this case, all I'm going to do is take a and b, those two numbers, and I'm going to plug them in for a and b in the expression. So we have 6 multiplied by 3 plus 3 multiplied by negative 5. This is the same thing as saying 6 times 3 is 18. 3 times negative 5 is negative 15. So 18 plus negative 15, well, this works out to being positive 3. Okay, positive 3. For question B, we're going to do the exact same thing. So I wonder if I can kind of section this off from the top, just so it's not confusing. We go down. Perfect. We have negative 9 plus b squared. Sorry, negative 9a plus b squared. So all I'm going to do is I'm going to substitute those values. I have negative 9 multiplied by negative 4 plus Well, b squared, they're just saying 5 squared. -9 multiplied by -4. Well, a negative times a negative is a positive, and 9 times 4 is 36. So we have 36 plus 5 squared. This is not saying 5 times 2. This is saying 5 times 5. Which in this case is 25. If we take these two numbers and we add them, 36 plus 25, we get 61. So positive 61, I guess you can say. Positive 61. That last question, 11a plus -6b. Same thing. All we're doing is taking the values of a and b. So a is 2 and b is -4. And we're going to substitute those into the equation. We have 11 multiplied by 2 plus -6 times -4. 11 times 2 is 22 plus, well, 6 times -6 times -4. Well, 6 times 4 is 24. And two negatives multiplied together, this is 24. Positive 24. 22 plus 24, this is positive 46. That's that answer for question C there. The very last question on this assignment, it says Mr. Dobson thinks that -3 times -5 is -15. His colleagues think that the answer should be positive 15. Who's correct? And explain your answer. So we have to take a look at what Mr. Dobson thinks here and what his colleague thinks. Have a good one, Ratmus. See you later. We have -3 multiplied by -5, and Dobson is saying, well, that's clearly -15. But his colleague thinks that it's positive 15. So we have to think about our integer rules when we multiply negative and positive numbers. Well, when I multiply two positives, I get a positive. When I multiply two negatives, I also get a positive. When I multiply a positive by a negative, I get a negative. And when I multiply a negative by a positive, I also get a negative. So based off of what Dobson is saying, okay, we have a -3 and a -5. We need to pay attention to this rule right here, where he's multiplying two negative numbers. And that final result should be a positive number. Dobson is saying it's a negative number. And in this case, he's wrong. His colleague is the one that's right. So we could write a statement that says something like, Mr. Dobson's colleague is correct because multiplying two negative numbers will result in a positive. Two negatives make a positive. Okay. So I hope that kind of gives a pretty good explanation about that question, as well as all of these other ones, right? Like, we've sat down for almost 33, 34 minutes working through this assignment. And that was me also explaining all of my thinking. So I hope that this kind of gives you a good idea about how long something like this might take. I also wasn't using a calculator, and you're more than welcome to use a calculator in order to get this stuff done, as well as, photo math, or aid yourself with Google as a piece of tech. But typically these tasks, I apologize, that was probably quite loud. I dropped my pen. Typically these assignments, they only take anywhere from 30 to 40 minutes, and you only get like 1 or 2 a week. So I hope that this video proved to be a little bit useful. If you got things wrong on the assignment after you've checked your mark, I hope that this kind of gives you an indication as to where you might have stumbled and how you can kind of try to correct your algebraic skills. Thank you very much for watching. I know it was a strange format. It was in the form of a live stream, but I very much appreciate you taking the time to watch this. And have a wonderful night, or have a wonderful day, or have a wonderful afternoon. It's up to you, I guess.